In getting ready to implement OSPF, let's do a quick checklist. Number one, we have identified how the OSPF router gets a router ID. Secondly, we identified how to enable the router process for OSPF. Third, we've also taken a look at network statements, which allow the directly connected networks to get into OSPF. Now, the last piece here is to go ahead and configure it. And to that end, let's have some fun with this. And let's imagine that our boss walked up to us and gave us a list of things that he or she wanted us to do regarding OSPF. So let's review the list together, and then we'll tackle it with the lab. And here's the list. So we want to add loopbacks to all routers using the router number YYYY/32. That means that if we're on R1, we'd create a loopback of 1.1.1.1 with a 32-bit mask. For the loopback, R2 would be 2222, etc. Great, we can do that. Now, one of the benefits of doing that early is that if we have a loopback interface, when we kick in OSPF and start it, it's going to choose for the router ID, it's going to choose the highest loopback IP address. And if we only have one on that router, that's the one it's going to choose. That's going to make it very handy to remember what the router IDs are for OSPF based on the loopbacks on those routers. And then the list continues. Now, if you want to pause this right now and read the entire task list, that's fine. But what I'd like to do is let's tackle one step at a time. So let's go ahead and do the first task of going to each of the routers 1, 2, 3, and 4, adding the loopbacks, and then we'll come down, we'll check that off the list and come down to step number 2. And as a refresher, here is our topology we'll be working with R1, R2, R3, and R4. We'll start with R1. So in the virtual lab environment, you just click on the link for the virtual lab, go to the management computer, which is DCNUG, and we'll launch PuTTY from there. All right, so here on DCNUG, I have a little image of the topology if you want to double click on that to have it at fingertip reference. And as that comes up, there we go. You can make that any size you want. And then let's go ahead and open up PuTTY. Upper left-hand corner. Then we'll open up connections, click on servers, go to R1, go to servers again, R2, servers again, R3, and servers again, and R4. Fantastic. Then we'll clean that up a little bit by pressing enter a few times, and we are ready to go. All right, so let's start on R1. Now, a great technique and habit to get into is that before we start configuring a network device is to verify a few basic things about it. Like if we think the interfaces are already up or we're not sure if there's loopbacks, let's do a show IP interface brief just to verify what's out there. So this confirms that we have 3 interfaces that are up. Fantastic. We currently don't have a loopback 0, so we can go ahead and create one without the accidental overriding or changing of an existing loopback. So let's create interface loopback 0. Config T, interface loopback 0, press enter, and then we have the IP address of 1.1.1.1 with a 32-bit mask, and boom, we're done. And now what I'm also going to do is after we've gone out of configuration mode, I'm going to do a show IP interface brief again, just to verify that what we think we configured got configured. So there's our loopback 0, and it is up. Fantastic. We're ready to go to router 2. So here on router 2, we'll do a show IP interface brief. And we have 4 interfaces here that are up and configured. Fantastic. And so we'll go into configuration mode, interface loopback 0, and I'll type that correctly. It's not as easy to type and talk as it used to be for me. Anyway, interface loopback 0, and we'll give it the IP address of 2.2.2.2 with a 32-bit mask. Awesome. And we'll do a couple up arrow keys, show IP interface brief, and there it is as our last entry. Super. We're 2/3 of the way done with loopbacks. Router 3, config T, do show IP interface brief, and that has 4 interfaces as well. They're up and configured. Interface loopback 0, IP address 3.3.3.3 with a 32-bit mask. All right, and then we'll verify that. That looks good, and then we'll go to router 4. And we'll do show IP interface brief, press enter, and there is our loopback. Okay, great, good to go. We've got 4 loopbacks on 4 routers, and those loopbacks, because they're the only ones, those will be the router IDs when we enable OSPF. All right, sweet. So we've added loopbacks to all routers. We've used the correct IP address for that loopback. So I'm going to check there. And what I'd like to do is let's go ahead and do one more task in this video. We'll summarize what we've done, and then we'll continue on in the next video or two with the remaining parts as well. That way we can all take nice, easy chunks of data, nice, easy labs, practice them, rehearse them, make sure we're comfortable before we move on. So our second task here is on R1, use a single network statement and area 0 for all networks. So what does that imply? That implies that we are going to use a wildcard mask of 255.255.255.255 because that wildcard mask says, I don't care about matching on any IP address. I want all possible networks on this router to become part of the OSPF process. So let's go to R1. We'll do that. I'll also share with you a few verification commands that are really important just to verify that what we think is happening on the router. So it's back to router 1 we go. So back to the console. We'll go to the tab for router 1. And so the interfaces that R1 has are 10.1.0.1, 10.12.0.1, 10.13.0.1, and also this loopback of 1.1.1.1. And if we do a show IP route, that's the other side of this picture. If we do a show IP route, that's going to show us the actual networks associated with those interfaces. So we have the 1.1.1.1 network, 32-bit network. We've got the 10.1.0 with the 24-bit mask, the 10.12.0 with the 24-bit mask, and the 10.13 with the 24-bit mask. And I think the task said, please include all networks with one network statement. So we're going to use the wildcard mask. So we'll go into configuration mode, and from a video that we had a couple of videos ago as part of the skill, to enable the OSPF routing process for IPv4, the command is router space OSPF space and then a process ID number. So this number can be any number of your choice. It's only local to the router itself. So we'll go ahead and put a 1 in there, press enter, and now we're in router configuration mode for OSPF. And here we're going to use the network statement, network space, and the proper way of stating a network command where we're going to use wildcard bits across the board is 0000, following it up with 255.255.255.255, which, as a reminder, simply means I don't care, I don't care, I don't care, I don't care, regarding the first 4 octets of the IP we put in here. All right, then we're going to follow that up with a question mark, and we're going to specify area, space, and we are going to, for this lab, we're going to put all of the networks into area 0. We're just going to use a single area and have all the routers and all their networks become part of that same area. So we'll put in area 0. Also, I've seen people do like this, quad 0, which effectively would mean the same thing. But as long as you're consistent with all your routers, it'll be fine. I'm just going to use area 0 with a single digit and press enter. And poof, it's done. Can you feel it? Can you feel the change? Now, a great question is, this router all by himself, running OSPF all by himself, not too helpful for the rest of the network and learning from the other devices on the network. But check this out. We can verify right here whether or not we have those interfaces and those networks included. Some of the commands we could issue include show IP OSPF to begin with. So show IP OSPF. That's going to confirm our router ID, which is great. There's a lot of other data on here too, but that's the part I want to share with you right now. It's also showing us at the tail end of that show IP OSPF that we are connected to area 0, backbone. Now it says inactive because we don't have anybody else to talk to right now. There's no other routers currently active on the backbone in area 0, but we'll fix that in a relatively short period of time as we add other routers. The other thing we could do is do a show IP OSPF interface, and let's start off with brief, because that way it'll give us a nice brief output of any interfaces that have been included in OSPF due to the network statement. And here we go. We got all of them. We have loopback 0, gig 20, 10, and 00 with their respective networks. Fantastic. They're all included. And if we wanted to see great detail on each of those interfaces, we could do show IP OSPF interface, take off the brief, and then pack a lunch because there's a lot of detail on each interface regarding OSPF. So loopback 0 is here, then we have gig 20 and all the details about it. And if we continue on with either the enter key for one line at a time or spacebar for one page at a time, it'll give us more details on each interface that's participating in OSPF. And there's one other command I'd like to share with you that's very helpful if we have the question, hey, Mr. Router, are you running any dynamic routing protocols? And that command is show IP protocols. Press enter, And that will show us a list of any dynamic routing protocols that are running on the system. So let's finish it up with that one. Show IP protocols, press enter, and this says, yeah, OSPF is running. And check it out. This reflects the network statement that we added, which basically says any interfaces that have any IP addresses, their directly connected networks are going to participate and be involved in OSPF and be associated with Area 0. So in this lab, we've had the opportunity to add loopback interfaces to all 4 routers. That'll help confirm what the router ID is going to be for OSPF. And we enabled OSPF on router 1. We also set up a network statement to include all interfaces on router 1 and their directly connected networks to be included as part of OSPF. And we'll continue in our task list as we work our way down it, continuing in the next video. So I'll see you there. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.